I want to talk today about solution stoichiometry, and we're going to look at a couple of problems. The first problem or question we're going to look at is, how many grams of Na2SO4 can be made from 20 milliliters of a 0.20 molar solution of NaOH, and we're actually referring to this reaction in that question. H2SO4 reacting with NaOH to make water and Na2SO4. This is standard acid, strong base reaction where you get water and a salt as your product. And in this reaction, the path that we're going to follow to do our calculation is to go from moles per liter, our concentration of known, to moles of known, to moles of unknown, to grams of unknown. And remember, anytime I give you a concentration and a volume, it's the same thing as me giving you moles of something. So we're going to take our volume and we're going to multiply that by our concentration, which I've rewritten from molarity into moles per liter, which is a much more useful way to write it because the liters cancel out, leaving us with just moles. If we look at our chemical equation, the ratio of Na2SO4 to sodium hydroxide is 2 to 1, or 1 to 2. The molar mass of Na2SO4 is 119.06, meaning that when we finish the calculation, we get 0.238 grams of Na2SO4. The second problem I want to look at looks a little bit more complicated, but it's really very similar. We're taking manganate ion and reacting with iron plus 2, and the question that we're going to look at this time is if it takes 47.20 milliliters of 0.02240 molar manganate ion to react with 30.00 milliliters of iron plus 2, what is the concentration of iron plus 2? You want to be careful with a problem like this because people see two volumes and two concentrations, one known and one unknown, and they a lot of times immediately think they're doing a dilution problem. You're not doing a dilution problem here. You're doing a chemical reaction. When you're doing a chemical reaction, it's a stoichiometry problem. The only time you can use the dilution equation, M1V1 equals M2V2, is when you're doing a dilution. I'm taking some stuff, I'm adding water to it to dilute it. So be careful of that. The path that we're going to follow in this stoichiometry problem is to go from moles per liter of known to moles of known to moles of unknown, and then to concentration of unknown. So we start with our volume in liters times our concentration, which again I've switched from molarity to moles per liter. The chemical equation tells us that there are 5 moles of iron plus 2 for every 1 mole of manganate. And that means we have this many moles of iron plus 2. Well, we know that that iron plus 2 was in 30.00 milliliters of iron, of 30.00 milliliters of solution. So we use our definition of molarity, moles per liter, to come up with 0.1762 molar for the concentration of the iron. And actually it says plus 3 here. This really should say plus 2. That is a typo, and I can fix that. Iron plus 2.